Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 5, and today we're looking at Section 5.4 on special products. In this section, we'll multiply two binomials using the FOIL method. We'll square a binomial. We'll multiply the sum and difference of two terms. And finally, we'll use special products to multiply binomials. And as usual, throughout this chapter, we are covering SLOA, which is performing mathematical operations on algebraic expressions. All right, so in the last section, we talked about multiplying binomials using the distributive property. So I want to review that really quick and then show you how we can get the FOIL method out of that. So let me switch over to my tablet, where I've actually got this problem all worked out already. So we're multiplying 3y minus 5 times 2y minus 7. So this time I'm distributing the 2y minus 7. That's something you're allowed to do. So that gives me 3y times 2y minus 7 minus 5 times 2y minus 7. And after you distribute the 3y and the negative 5, you end up with these four terms: 3y times 2y, which is the product of the first terms from the binomials, 3y times negative 7, which is the product of the outer terms from the binomials, negative 5 times 2y, which is the product of the inner terms, and then negative 5 times negative 7, which is the product of the last terms. And that's where we get FOIL: first, outer, inner, last. All right, so let's switch back to the presentation. All right, so this is basically what you just saw on the tablet. FOIL stands for first, outer, inner, last. And so I guess the one thing I could do is finish off this problem. So let me go back here. Oops. Okay, so just like if you use the distributive property, when you use FOIL, you end up with 6y squared minus 21y minus 10y plus 35. And of course, we're going to combine the like terms. So our final answer is going to be 6y squared minus 31y plus 35. All right, so I'll just stay here for the moment and look at the first example. So in these two problems, we're going to multiply using FOIL. So first, outer, inner, last. We have 6x times x, which is 6x squared. Outer is 6x times negative 2, which is minus 12x. Inner is 2 times x, which is plus 2x. And last is 2 times negative 2, which is negative 4. We'll combine the like terms. We get 6x squared minus 10x minus 4. And it also works if you have some fractions in your binomials. First, outer, inner, last. X times x is x squared. Outer is x times 1/5, which is 1/5 x. Inner is minus 2/5 times x, which is minus 2/5 x. And then last is negative 2/5 times 1/5, which is negative 2 over 25, right? Combining the like terms, we get x squared. 1/5 minus 2/5 is negative 1/5. So that's going to be minus 1/5 x. And then minus 2 over 25. All right, so back to the presentation. We're going to start looking at our so-called special products. Oh, and this is a silly little math joke. So you have the binomial P plus L times A plus N. Your plan has been foiled. I have that on a t-shirt because of course I do. All right, so we already did this. All right, so now we're going to talk about squaring a binomial. We did at least one example of this in the last section. So let's look at these first two examples. We'll do them the same way that we did them in the last section. So the first thing I have to remember is that the square of x plus 7 is not the square of x plus the square of 7. I wish that's how it worked, but it actually means x plus 7 times itself. So this is the kind of thing we can FOIL. We're going to find what I think is an easier way to do it here in just a minute. So FOIL. X times x is x squared. X times 7 is 7x. 7 times x is also 7x. And then 7 times 7 is 49. All right. So what I want to point out to you is that x squared is, of course, the square of x. 49 is the square of 7. And then these two terms in the middle are exactly the same. And so we can think of that as 2 times 7 times x. But when we go to write the final answer, it's going to be, let me create some separation here. X squared plus 14x plus 49, right? Okay, the square of 7x minus 3. So again, that means 7x minus 3 times 7x minus 3. When you FOIL that, you get 7x times 7x, which is 49x squared. 7x times minus 3 is minus 21x. Minus 3 times 7x is another minus 21x. And then negative 3 times negative 3 is positive 9. So what I want to point out to you this time is that 49x squared came from the square of 7x. 9 came from the square of 3. All right, and then there are two of these terms that are exactly the same. Minus 2 times 7x times 3. And our final answer would be 49x squared minus 42x plus 9. All right, so you will find it very helpful, especially in the next chapter, chapter 6, if you know this pattern. So the pattern looks like this, depending on whether the binomial you're squaring is a sum or a difference. So notice that ignoring the signs for just a second, the three terms are a squared, 2ab, and b squared. The last term is always going to get a plus because in this case, you're doing b times b, and in this case, you're doing opposite b times opposite b. So in either case, it comes out to plus b squared. The only thing that's different, depending on whether this is a sum or a difference, is that if it's a sum, then the 2ab term gets a plus, and if it's a difference, then the 2ab term gets a minus. All right, so now let's try these two examples using the pattern. I'm not going to FOIL this time. Switching back to the tablet. First example is 5a plus 2 squared. So notice this one is a sum. So this is going to have the pattern a squared plus 2ab plus b squared. So what I like to do is just set up space for my answer, which is going to look like blank squared plus 2 blank blank plus blank squared. And you fill in the blank with the two terms from the binomial. So this one's going to be a 5a. This one is also a 5a. This one is a 2. This one is a 2. Okay. So that gives you 25a squared plus 2 times 5a is 10a. 10a times 2 is 20a. And then the square of 2 is 4. So that's at least as easy as doing FOIL. And again, knowing this pattern will really help you out in chapter 6. As usual, at any time when you want to try a problem ahead of me, just pause the video, try the problem, come back and compare notes. So maybe you'll do that with letter B. So the main thing I want to point out about letter B is that because we're squaring a difference this time, the pattern is a squared minus 2ab plus b squared. So this one is going to be blank squared minus 2 blank blank plus blank squared. 6s goes here and here, 2 goes here and here. And our final answer is 36s squared minus 2 times 6s is 12s. 12s times 2 is 24s plus 4. All right, so I think I just have one other thing to show you, and it's kind of my favorite. And that is the sum and difference of two terms. I don't remember if we've done an example like this before. I can't remember if I had one of these in the last section. So let's try these two problems using FOIL. Starting with b plus 3 times b minus 3. So using FOIL, you would get b times b is b squared. B times negative 3 is minus 3b. 3 times b is plus 3b. And then 3 times negative 3 is negative 9. So now something happens that's kind of special. The minus 3b and the plus 3b cancel and just leave you with b squared minus 9. So this doesn't happen very often when you multiply two binomials and the answer is a binomial. What I want to point out to you about these two terms is that this one is the square of b, and this one is the square of 3. And notice there is a minus in the middle, and that minus came from 3 times negative 3. All right, so now let's try this one. 4x minus 5 times 4x plus 5. 4x times 4x is 16x squared. 4x times 5 is plus 20x. Negative 5 times 4x is minus 20x. Negative 5 times 5 is negative 25. So once again, the middle two terms cancel, leaving you with 16x squared minus 25. Notice that 16x squared is the square of 4x, and 25 is the square of 5. And again, you have that minus in the middle. All right, so the pattern, when you multiply the sum and difference of two terms, is a plus b times a minus b will always come out to a squared minus b squared. And by the way, I don't have it written down, but the order of those binomials doesn't matter. So if it was a minus b times a plus b, you would get the same answer. All right, so now we'll try these two problems using the pattern, and then that's going to do it for this section. So let's go back to the tablet one last time. These are very easy to do with the pattern. I definitely recommend doing them that way and not with FOIL. First, notice that the two binomials have the same two terms. 10x and 2/7. But one of them is a sum and one of them is a difference. So that means this pattern is going to fit. This is your a plus b. This is your a minus b. Okay, so when you multiply them together, you get a squared minus b squared. So what I will usually do is just write blank squared minus blank squared. Fill in the blank with 10x and 2/7. And your final answer is 100x squared minus 4 over 49. That's it. All right, and then the last example, 5x squared minus 1.3 times 5x squared plus 1.3. Again, you have the same two terms. This time it's 5x squared and 1.3, but one is a sum and one is a difference. So it's the same pattern, blank squared minus blank squared. This time I'm going to fill in the blank with 5x squared. So that might be a little tricky. Notice that one's already squared, so it's going to get squared again. This one is 1.3. So my final answer is going to be 25x to the 4th minus the square of 1.3, which is 1.69. All right, and that's going to do it for section 5.4. We'll see you next time.